Hello students, today I will discuss planning questions. This planning questions is important for Cambridge IGCSE and Cambridge O-level chemistry practical and ATP paper. This is important for practical question paper and alternative to practical paper. Let's start. This is planning lecture 1. You are asking plant leaves contain a mixture of colored substance that contains plant leaves, different mixture of color substance. Plan an experiment. You have to plan an experiment to find the RF values of the colored substance present in the plant leaves. Your plan should describe the use of common laboratory apparatus, plant leaves, sand, ethanol as the solvent, and absorbent paper. You may draw a diagram to help answer the questions. Now you see first we can find the RF values by chromatography. Which method? Chromatography method. We can find the RF values by chromatography. Method name is chromatography method. First, plant leaves are crushed using pestle and mortar. By using pestle and mortar, plant leaves are crushed with sand and solvent ethanol. First, we can find the RF values by the chromatography method. Plant leaves are crushed using pestle and mortar with sand and ethanol. Then the liquid is filtered. You will get filtered clear solution. Then a line is drawn here in pencil near the bottom of the paper. This line is drawn near the bottom of the paper. The spots of the liquid are placed on the paper. Then the spot, this one spot, two spots are placed on the paper, on the pencil line. Then the paper is placed in the solvent. Then this paper is placed here, solvent. This is the solvent. This line is the solvent front. And the solvent travel up the paper. Then RF value is calculated. RF value is calculated and the solvent travels up the paper. Then RF value is calculated. How? RF value equal distance traveled by the substance or distance traveled by the color substance divided by distance traveled by the solvent. This RF value equal distance traveled by the substance, say baseline to this substance distance if A, baseline to solvent from distance B, so RF value will be A by B. This is the method of to calculate RF value. We can find the RF value by chromatography method. At first, plant leaves are crushed using pestle mortar with sand and ethanol. Then the liquid is filtered. After that, a line is drawn in pencil near the bottom of the paper. A line is drawn in pencil at the bottom of the paper. After that, the spots of the liquid are placed on the pencil line. Here on pencil line, spots of liquids are placed. Then the paper is placed in the solvent and the solvent travels up the paper and the solvent moves the paper, moves up the paper. Then RF value is calculated by the method RF value equal distance traveled by substance divided by distance traveled by the solvent. This is your planning lecture 1. Thank you, dear students. Let's move. The diagram shows some coffee beans. Caffeine occurs naturally in coffee beans. Caffeine is a white crystalline solid. It is very soluble in hot water but much less soluble in cold water. That means caffeine is very soluble in hot water and less soluble in cold water. Plan an investigation to obtain a pure crystalline sample of caffeine from coffee beans. Assume that all other soluble substances in coffee beans are very soluble in both hot and cold water. You are provided with coffee beans and common laboratory apparatus. Now you see the answer. At first, coffee beans are crushed or grinded using pestle and mortar. Coffee beans you will grind by using pestle and mortar. Then water is added and stirred. Then heated to dissolve. Then if you give heat, coffee beans will dissolve and other soluble substance also dissolve. Then the mixture is filtered and the filtrate is left to form crystals. If you filtrate is kept, then caffeine will form as a white crystalline solid. So then the crystals, caffeine, are filtered and washed. So soluble impurities will remain in solution. You see that all other soluble substances in coffee beans are very soluble in both hot and cold water. So first, you see, coffee beans are crushed or grinded using pestle and mortar. Then water is added and stirred. After that, the mixture is heated to dissolve. Then caffeine will be dissolved. The mixture is filtered to remove solid impurities. And the filtrate means the clear solution is left to form crystals. Filtrate is left, so caffeine crystal will form. After that, then the crystals are filtered, washed and dried. You will get white crystalline solid of caffeine. White crystalline solid caffeine. I think you can understand and you can listen again. Coffee beans are crushed or grinded to powder. How? By using pestle and mortar. By using pestle and mortar, coffee beans are crushed into smaller particles. Then you will add water and stir. Then coffee beans will dissolve, caffeine will dissolve and other substance will dissolve. But solid impurities will not dissolve, and also you will give heat to dissolve. Then the mixture is filtered to remove solid impurities and the filtrate is left to form crystals. If you keep filtrate, then caffeine crystal will form. After that, the crystals are filtered, washed and dried. You will get a white crystalline solid of caffeine. Thank you dear students. Please subscribe, like and share my channel. Hello students, this is my planning lecture 3. This is important for Cambridge IGCSE chemistry and Cambridge O-level chemistry practical and alternative to practical paper. This is planning lecture 3. Copper 2 sulfate is a salt used to kill pests on plant leaves. Copper 2 sulfate crystals is prepared by neutralizing dilute sulfuric acid with solid copper 2 oxide. I mean copper 2 oxide reacts with sulfuric acid to produce copper 2 sulfate. So plan an experiment to prepare pure dry crystals of copper 2 sulfate. So you have to plan how you can prepare pure dry crystals of copper 2 sulfate. I mean copper 2 sulfate crystals, how you can prepare from solid copper 2 oxide and sulfuric acid, you are asking. And your plan should include the use of common laboratory apparatus. You can use dilute sulfuric acid and solid copper 2 oxide you can use. Now you see what you will do. At first you will take a beaker, then excess copper 2 oxide CuO and dilute sulfuric acid aqueous aqueous is taken in a beaker and heated. First, excess copper 2 oxide and dilute sulfuric acid are taken in a beaker and you give heat. Here copper 2 oxide, excess copper 2 oxide and dilute sulfuric acid, copper 2 oxide plus sulfuric acid. Then you give heat. Excess copper 2 oxide and sulfuric acid is taken in a beaker and heated. The solid copper 2 oxide is dissolved and blue solution is produced. Blue solution is formed. After giving heat, you will see solid copper 2 oxide dissolve and blue solution will be formed. The mixture is filtered to remove excess copper 2 oxide. As you have taken excess copper 2 oxide, so all copper 2 oxide will not dissolve. Some extra copper 2 oxide will remain undissolved, not dissolved. So you need to be remove that extra copper 2 oxide. That's why the mixture is filtered to remove excess copper 2 oxide. When you mixture filtered, excess copper 2 oxide remove and you will get filtrate clear solution, clear blue solution you will get. Then what you will do? Then the filtrate is heated. The filtrate is heated to the crystallization point. The filtrate, I mean clear blue solution, you will give heat, and up to when you will give heat, how much time you will give. When you see crystals start to form, then you stop heating. Crystallization point means the point where crystals start to form. So the filtrate is heated to the crystallization point and allowed to cool. When you see crystals start to form, then you stop heating and you left it to cool. After some time, when the mixture has been cooled, you will see copper 2 sulfate crystals are produced. You will see copper 2 sulfate crystals, means solid, produce. Then the crystals are filtered off. The crystals are separated by filtration. This is mean the crystals are filtered off, then washed. Why washed? To remove crystal surface impurity. It may contain some impurity on the surface of the crystal. So if you washed, surface impurity will be removed. Washed with cold water, washed with solvent, or washed with distilled water, and dried in a warm place. Or you can dry in a warm place. This is the drying method. Or you can write the crystals are filtered off, washed and dried in a warm place or between filter paper, or the crystals are dried on filter paper, you can write. And you see copper reaction, copper 2 oxide is solid, sulfuric acid as dilute, so aqueous, and copper 2 sulfate aqueous blue solution is formed. This solution is blue color solution, and water is liquid. So this is the reaction. So at first what we will do, excess copper 2 oxide and dilute sulfuric acid is taken in a beaker and heated. You will take a little bit more than needed copper 2 oxide, that's why excess, and dilute sulfuric acid is taken in a beaker and heated. After giving heat, you will see copper 2 oxide is dissolved and blue color solution is formed. Then what you will do, The mixture is filtered to remove excess copper to oxide. The mixture is filtered to remove excess copper to oxide. When you will remove excess copper to oxide, you will see clear blue solution. This is known as filtrate. The filtrate is heated to the crystallization point and allowed to cool. Crystallization point means the point where crystals start to form. When you will see crystal starting to form, that means you can understand that the solution has been saturated, and this is known as crystallization point. After reaching crystallization point, you stop heating and left for cool, allowed to cool. After cooling, you will see copper to sulfate crystals are formed. Then the crystals are filtered off, washed and dried in a warm place. Then you will get pure copper to sulfate crystals. So what type of reaction? Copper to oxide is a base and acid. This is neutralization reaction. So this is the method for the preparation of pure copper to sulfate crystals from copper to oxide and sulfuric acid. Thank you dear students. Please subscribe, like and share my channel, and you press on playlist for your own content.